Okay, this problem is 6.3, number 24 online. This is the problem about the men's and women's heights in the doorway. I'm going to leave that on the screen for a few seconds so you can pause it and write it down. Now I'm going to zoom out and see if we can do this problem. First thing you do is draw a picture. And we'll draw a picture. If I can find a pen. It says men's heights are normally distributed with a mean of 68.8 and a standard deviation of 2.8. So 68.8, 2.8 would be 71.6, and 2.8 would be 70, let's see, that'd be 74.4. You just have to check my math. 68.8 minus 2.8 would be 66. And 66 minus 2.8 would be 63.2. Again, check my math on those. I'm doing them right off the top of my head, so I may be off a little bit. But anyway, it's not going to throw your answer off because you just draw it for a visual visual effect, so you'll know, what's going on with the curve. And basically, that's the men. I think men's heights. That's men. And women, I don't know why I picked two dry pens to work with. 63.3 and 2.5 would be 65.8, and 2.5 again would be 68.5. And then 63 minus 2.5 would be 60.7, somewhere in there. I have my calculator with me, but anyway, 60.7 minus 2.5 would be around 57.5 or 57.2, somewhere around there. Again, that's not a big deal because we are just drawing a graphic presentation. Get another marker here. So we've just basically done the first two lines, men's and women's. Now, it says for A, it says the percentage of men who are too tall to fit through a standard door without being bending. Find the percentage of men who are too tall to fit through the standard door. It says that the standard doorway is 80 inches. So 80 for men would be right in here. I'm going to put 80 right up here at the top. Okay? Now, we are given enough information to get a z-score. So that would be z of 80 inches is equal to x, which is 80, minus 68.8 over, and our standard deviation for men is 2.8. And I loaned all my calculators out, so I'll have to use my phone because I haven't done this, so we'll use my phone if I can find it. And get to a calculator. There we go. And that would be 80 minus 68.8, and y'all can be doing this with me, equals divided by 2.8, and that gives us a z-score of 4, which is way out there. Now, z-score of 4, we need to look up in our z-table. That's a positive z-score because it's on the right side of this big line right here, so anything to the right of this is positive. Anything to the left of this is negative. So positive 4. We look on our handy dandy table, which they give you in the problem. We don't need negative, we need positive, so we flip over to the positive and we look for a z-score of 4. Now what I'm going to do is I'm going to try to zoom into this a little bit where you can see it a little bit better, but you should have your own copy. All you got to do is print it out, which I know for some of y'all that's kind of difficult. But anyway, it says right here 3.5 or more is 0.99999. So that means that to the left of 80, or a z-score of 4, is 0.9999. So that means this little proportion on the right here, I'll do it in a different color. I'll do it in green. This little area right here that I can't get the pen, there we go. This little area right here is 0.0001. So the answer to our question is 0.0001 probability that men are too tall for the door of 80 inches, or 0.01% of men are too tall. And that is how we do A. Now, A also says the percentage of women too tall. Well, again, that would be over here. Let me get over here a little bit where you can see. That would be right here, 80. So we would do 80, the Z sub 80 for women is equal to 80 minus 63.3 over, and their standard deviation is 2.5. So let's take our handy dandy calculator out, and we will do 80 minus 63.3, and that's equal to 1.26 divided by 2.5, and that comes out to be, well, that's not right. Let's try it again. 80 minus 63.3, I think I might have hit the wrong button. There it is, divided by 2.5. 6.68, which is even further out than the men. And that's equal to 6.8. And 6.8 is more than 4. So that's going to give us, again, the little note in the book that says 0.0001 probability of women are too tall for the 80-inch door, or 0.01% is too tall for the door. So let me zoom out. For A of this problem, you got the same answer because both are way off the scale as far as height of 80 inches. And that is part A. Part B, I'll go to another piece of paper here. Part B says the statistician would design a house with doorway height of what? Well, let's go back to, if a statistician designs a house so that all the doorways have heights that are sufficient for all men except the tallest 5%. The tallest 5%. Well, the way we would do that is we would draw another picture, B, draw another picture, and that's why you draw a picture on these, because it makes sense if you draw a picture. They want the tallest 5%. So the tallest, we know this is 2.5 because of our empirical rule of our 34, 34, 13.5, 13.5, 2.5, and 2.5. So 5 would be right in here. So this is the tallest 5%. That means the left-hand side, and I'm going to do it in another color. Do it in our green marker again. if this on this side right here is 0.05, then this is 0.9500. That's just the complement. 1 minus 0.05, or 1 minus a nickel, is equal to 95 cents. So let me write that down. 1 minus 0.0500 is equal to 0.9500. So our table A2, will give us this z-score right here that's comparable to 0.9500. So you take your handy dandy positive z-score table, and I'm not going to zoom in because you should have it, and we're going to look up 0.9500. 0.9500 is right in the middle of the table, and you follow it down, it says 0.95 is equal to 1.645. So that z-score is 1.645. Now, we've got a z-score, we've got to change it into x. X is equal to Oz plus mu. Standard deviation, z-score, and the mean. X is equal to standard deviation for the mean is 2.8. Z-score is 1.645, and mu is 68.8. Add all those together, and let me get my calculator, and that will be 2.8 times 1.645, and that gives us 4.606 plus 68.8, and that's equal to 4.606, 73.46. And they tell you to round to the nearest, okay, instead round to the nearest tenth. I got 73.5, but they may have 73.4. It depends on your rounding. And that should be your answer. I hope that helps.